So let's investigate the masses of the first generation of quarks, the d quark and the u quark. You can see the d quark here is composed of a generic U and a boson minus. And as seen previously, the generic U quark will give us a mass of 2,500 electron units. Now, it was noted previously that when you have a boson minus scalar boson, it will have a mass factor if it has a combinatorial value of 2. Well, in this case, we can see that the combinatorial value is actually -2. And so since it's -2, we actually have an inverse factor. So instead of multiplying this scalar boson, will actually lead to a division of the mass on the U quark. So we'll see that now we have the mass on the d quark, which is 25 electron units. So let's continue now by looking at a possible composition of the U quark. In this case, we have a generic d quark, and as seen previously, the mass on the generic d quark is 500 electron units. Now, instead of a boson minus, we have a boson 0, so that we're going to, by combining the generic d and the boson 0, we will get another configuration for d quark. And we see now, just as before, we still have the proportionate mass on the d quark of 25 electron units. And so here we have a boson plus composed of a flavored and anti-flavored particle. So the flavor is canceled. So this boson plus will have no mass factor. But if we go back and look again at the boson 0, we'll see that just as before, above, the combinatorial value was -2. And so we got an inverse factor. So our generic mass of 500 electron units was divided by 20, and we got a generic mass of 25 electron units. Now, even though this will have no mass factor, being a boson plus, it will have a electromagnetic effect, and therefore transform the d quark into a u quark and give us the mass of the u quark, which is 5 electron units. And so there we see in the first generation of particles where flavor is not a factor, but the primary ions are still a factor and produce inverse factors actually for the masses of the d and u quark when interacting with the generic quarks. And so these two videos you have seen how this Rishon-like theory is able to, in a way consistent with the proportionality of the standard model, articulate the masses of the 3 generations of quarks.